For number 3, we want to find the center of mass with the upper half of a ball or sphere with radius 16 and a density function. So this is in 3 dimensions, so we're going to have a center of mass written as a set of triple integrals. So the center of mass might look like the moment about yz divided by m, the moment about the xz plane divided by m, and the moment about the yx plane divided by m. So the yz plane is the plane that doesn't have x, so that is the rotational field that is going to have x in it. Now, I'm going to need to compute 4 triple integrals to be able to find the center. The first one is just the integral of the density function, that's our mass. Then we're going to have the integral of x times the density function, the integral of y times the density function, and the integral of z times the density function. Now, notice that your density function is given in spherical coordinates, so you won't actually be using x here. You'll be using what x is equal to in spherical coordinates. You'll be using rho sine phi cosine theta. The same thing for y and z, use their transformation in spherical coordinates. Also, don't forget that dv needs to be written in spherical coordinates. That's going to be your d rho d phi d theta, and don't forget your Jacobian, your change of variable multiplicative value here. You're going to need to multiply by rho squared sine phi when you change to spherical coordinates. Now for the bounds on the integral, since it's just the upper half of a ball or sphere with radius 16, your radius is going to be rho goes from 0 to 16. It's going to be the entire upper half, so your theta is going to go from 0 to 2 pi. And since it's just the upper half, your phi is going to go from 0 down to the x-axis.